here, but also in case you want to review it as well. Again, just for some good information. So hopefully you made it so far. Again, this is for week 5. So we have this week, our last class is 1 week from Tuesday, and that's when everything is due. And do know that the course project assignment in week 6 is optional. You do not have to do it. Whatever you submit final for this week, if you have completed, if you completed your course project, then it would, I'm sorry, I just got the feedback, so I muted person. So, okay, so if you are done with your course project in week 5, then you would submit the same thing in week 6. But obviously you have until that Tuesday of week 6 to submit everything midnight that day, and hopefully you'll get a chance to do so. And I do periodically go back in previous weeks to grade submissions that were maybe made after the due date. And as you know, there are no late penalties for this class because it is a work in progress and learning in progress. And again, as I stressed, don't submit it if it's not working. Keep working on it and submit it when it is successfully working and executing properly. So there was a lot of new material this last week and the last few weeks, but I think week 2 I gave you a video on help for your assignment. Week 3 I did not, but I gave you some source code, so maybe that helped for you to figure it out. But week 4 as well, I did give you some source code to help you with the assignment because I just wanted you to start thinking and researching and understand these problems and give them some good thought process. It does take time to come up with a design and a solution to a problem when you want to make a computer program. Doesn't necessarily come naturally, automatically. And I think a good practice is what many of you are doing, or if not, you should be doing, it may help, is if you manually trace your program. Again, you are writing this code. It's not something that's out of your hand or out of your control. So you really have to make your program your own. Not like I'm doing this and I don't know why it's not working. That means you didn't really understand what you wrote as a program. So really it's up to you to know what you're writing, make sure it follows the logic that you wanted to follow, and produce the results that you wanted to produce. It's all in your hands. There's no outside invisible programmer or controller of your program as you are creating it. So hopefully, I think a lot of things that I was giving advice on was if you found a method that, especially if you had example code, and you found a method that you didn't know what it was doing, then a good idea was to go to the API reference library to find out what did it do until you understood exactly what was its purpose for this code in this program. So you really need to understand every single line of code and also know the flow of each line of code so that you can follow it along and kind of mentally trace it as how the computer would process it. That'll give you an idea then of if it's going to work successfully or not. And if there are issues, you will kind of have a clue or a better understanding as to where that issue may have occurred. So it's really understanding every line of code and what it's doing. Some people do flowcharts. Flowcharts do help you, especially when you have a lot of decision statements or if you have loops. That's an area where you can very easily, by accident, leave one line of code outside of the loop when it should be in the loop, or a line of code that should be in the loop and it's not, it's outside of the loop. So having some kind of a visual representation of how your program is flowing and executing can be very helpful to make sure that your logic is correct, especially when it comes to like if then else statements or conditionals and loops. When you have the syntax checker, maybe will say, hey, you don't have matching braces and or parentheses, right? So it's just counting them. It's not necessarily knowing where they actually should go. So you really have to understand your logic to know where it should go. You can't just place it where the syntax checker is telling you to place it because that might not be the correct place. I'm sure you've witnessed this with all spell checkers, right? You can have a spell checker. A word can be spelled correctly, but it's not the right word for the sentence. This is a very similar process when it comes to syntax checkers. They're just pattern matching, and it doesn't understand your logic. It's not a programmer inside the machine telling you how to write your program. It's only up to you to understand it. So hopefully that was just some of the issues that I see and offered some clue into that online. But more importantly, I did want you to collaborate together. So I'm glad that you did reach out to each other, you helped each other, because again, this is a skill that's very helpful in the workplace. And also, it's a way for you to reinforce what you're learning by being able to explain what you did. That's why I always ask, share your strategies, because this kind of, sometimes you could just do something and say, oh, it worked, but I'm not exactly sure what I did or how I fixed it. All I know is works. All right. But really, you should know what is it that you did to fix it, and why did it work correctly, and why didn't it work correctly when it didn't? Because this will give you a sounder understanding of what your logic of your program is. So, well, with that, hopefully you're getting along. Any maybe preliminary questions right now before we get going with week 5? I didn't do grading yet, so I didn't get a chance to know how things were, but I'm assuming if your program worked, you submitted it, and if it didn't work, you still have time to submit it. And I saw a lot of interaction in the classroom and through email. But any questions so far? Anything? Yes, no, maybe so? You are hearing me, right? Thank you. So I don't know if you hear me, right? It's unknown out there. I think you're hearing me. I think I'm talking. I mean, I know I'm talking, but if you're hearing me. Okay, good. Okay, so let's go on. Week 5. Now, week 5, I'm going to give you some help for this one for sure. Definitely. It's in this presentation, so I will give you the slides as well. And we kind of touched on this a bit when we were talking about inheritance. So the topics for this course is to talk about interfaces, abstract classes, and different types of inheritance. Now, the library is full of class library. We know they're full of classes. They're also full of interfaces and abstract classes. At the end of the course, can we turn in assignments or partial? Yes, you may. But I have faith in you. I think you're going to get it. Reach out to your classmates. So I don't know why you wouldn't get it. But definitely when I'm going to talk about the course project, there's different parts. I mean, you just have to have, like 7 elements that your course project needs to have. So you have 6 or 7, you get an A. If you have 5 or 4, you get a B. If you have 3 or 2, you get a C. But also, that's only a part of your grade. Remember, the course project is just one element of your grade. It's not your entire grade. So, and that's only for week 5. So the rest of the weeks, you may be working well. So, but yeah, good question though. But let me know too when you submit it, because it may be an easy fix or a quick fix, and then you could fix it and then resubmit it and get the full credit. Okay, so the library is full of, now there's a difference between a concrete class, an abstract class, and an interface. And these are just the way the class is written, okay? An interface has some things that you have to use, but they're not completely defined. An example is a window, right? For when you create a window, for an application, a graphical user interface window, there's some things that are there for sure that you don't change, right? You have the X at the top right, which means to close. You have a title bar, you have a menu bar, or what have you. So these are things that you have to have, but they're not necessarily all defined. You have an option to define some of them, to customize them for what you want to do. But whatever it has, you have to use, okay? Abstract class kind of sort of defines things for you, but it gives you the opportunity to define it further so that you can use it for your program. Okay? It kind of gives you an idea of what you should have, but it can't give you complete definitions because it's pretty generic, and you need to then finish the definition so you can use it. And then single and multiple inheritance, and that's one thing Java does not do. Other programming languages like C++, you can have multiple inheritances, but in Java, you only can have a single inheritance, but with a mixture of uses of classes, inheriting classes, and using interfaces are a way to simulate a multiple inheritance. So that may be not necessarily something that you need to concern yourself with at the time, but just know, in general, Java does not do multiple inheritances. C++ does, when you get out there. Again, you're going to revisit this a lot more and more as you go on and throughout your academic career. A lot of this stuff is just revisited, and if you don't get it now, you will have a chance to get it in subsequent classes. So this is what you're going to read, interfaces and abstract classes. And you're going to talk about this. So that's one of your discussion questions. You're going to understand why you can't do multiple inheritance in Java and what multiple inheritance is. So this is part of your research to understand what this means. Now, this doesn't mean that you can have a hierarchy inheritance, like you'll have a parent, a grandparent, then a parent, and a child. That's different than multiple inheritance. That's just regular inheritance, and that's fine. Those are single inheritance because it's a single hierarchy where you go from grandparent to parent to child. So that's not what we're referring to when we're talking about multiple inheritances. So this discussion question will give you a chance to look into it and go look into it. How does C++ do this? Why is it that C++ or any C family programming language, why is it that they can do multiple inheritances, and what does that look like? What does that mean? Java can't, but what does it mean in C++? And why would you want to have it? What is the benefit? And what are the challenges? And that's why Java just doesn't have it. So, and I'll show you here, and you're going to give an example of how to use it by way of interfaces. And the same thing, when you reply to your classmates, offer code, check out their links. If you have a discussion, when you write your post, run your code. I keep urging you to do that, encouraging you to do that, because that's practice makes perfect in coding, period. But here we go. So we're going to talk about how an example of an abstract class, and this I believe is part of your assignment for this week. So this code you're more than happy to use. It may not be all the code that you need. There might be some additional things you need to add, but once you understand this, then you should have no problem in doing so. But the example here shows that we have an abstract class known as a shape. And what that means is it kind of is a class that applies to all shapes, but not exclusively to every single shape, because every shape is different. So there are some things that it'll have that apply to all the shapes, and it'll have a suggestion of what else you should have, but it can't define it because it's defined differently by each shape. An example for that is an area. When you get the area of a shape, how you get it for a rectangle is different than how you get it from a square, which is different than how you get it from a circle. Okay? So the abstract class says, hey, you have to have a method that calculates the area, but I can't define it for you here because it all depends on your shape. So this is then how you would use it. You would extend the abstract class, and then you would add your particular definition for an area because of the shape that you are creating this for. And the example here is a circle. So I can't define how the area is calculated in shape because it's all different for all different shapes. But when I create now this concrete example of this abstract class, I'm creating one for a circle. So I definitely know how a circle's area is calculated. So I can then define it. Okay, so that's the differences. Abstract classes give you as much as it can, but it can't give you everything. But it's there because it kind of gives at least a good amount of it. And again, the whole purpose of class libraries is just to make your programming faster and more efficient because what's in the library works. Okay. So here we have an example. This is an abstract class because it has abstract methods. So abstract class means there's some methods here that need to be defined. Okay. So every abstract class will have some abstract methods. okay? So the one it is get area, just like I mentioned, right? How you calculate the area will be different depending on the type of shape you have. And another one here is stretch by, and that's how to enlarge, make your shape larger. How you make a triangle larger, when you're putting it on vectors and using a graph and using your points on your graph. How you make a triangle bigger is different than how you make a circle bigger, which is different than how you make a rectangle bigger or smaller. I should say bigger or smaller. So that too cannot be defined in my abstract class, but it's here to say, hey, you should probably, if you're going to use this abstract class, when you are going to make it concrete, make sure that you add definitions for these methods because they are very useful to have, because people would maybe want to have different versions and sizes of a shape drawn out for their program, what have you. And definitely the area, if you need to calculate that, but it also differs from each shape, okay? So abstract methods, they're declared, but there's no definition. They have no implementation. They cannot be used as they are because they're not completed. Abstract class is a class that has the abstract methods. So you can't use an abstract class directly because it's not completed. There's things that need to be defined. And the interface is a named collection of method definitions. And again, this is the one that I mentioned is the abstract has some things defined, some not. Interface has things that you have to use. Everything in it you have to use. Nothing is optional. And it would have some basic definitions for most of it. I mean, like a window. A lot of things for interfaces, you use the window interface whenever you create a graphical user interface because it has, again, the standard way that a window looks. You have the X in the top right, you have a title bar, you have a taskbar, and so forth. So you'll learn more about that when you're going to do your discussion. But here's some examples. Food is an abstract class. Can you make an instance of food? No. But you can make instances or examples of food, like an apple or a steak or peanut butter cup. So these are types of food. So food is an abstract concept, and in order to use it, you have to have a concrete example. Okay? Skills are interfaces. Can you make an instance of a student, an athlete, or a chef? No, but you can make an instance of a person and have that person take on all these skills. Like I want to create a window, so I'm going to take on all the definitions for a window for my interface because it has already the standard definitions that windows need or use. There'll be some things you can change, like the title bar. You'll have options to put what you want displayed in your title bar. But the icons on the top right are always the same. Any window you go to, you always have the minimize, maximize, and close buttons. So some fine distinctions. Again, I'm glad that it's part of your discussion question because then you can get, these kind of can be fuzzy unless you start doing some additional research in it. Okay, so back to my shape classes. Okay, so in order, we now know about the abstract class shape. It's abstract because it has abstract methods. The two abstract methods are get area and stretch by. Now, in order to use an abstract class, you extend it. Okay? Now, here we go. So we know when you inherit something from a class, you can use whatever is in the parent class. For example, I already have some attributes for X position and Y position. Okay, if you're going to graph out and draw out a shape, you're going to have X and a Y. But our circle needs an additional one, and that's a radius. So all shapes do have an X and a Y, but some shapes maybe have additional things that they need, especially when they need to calculate a area. Okay, now we go on to final. When you see final, what that means is it can't be changed, it has to be used. I noticed some of you were using the final keyword in some of your assignments previous. And that is a way of making sure that it's used. We're creating an abstract class, right? And we want to always have if we're going to have an X position and Y position, we have to have a way to get that information. And that's going to be get X and get Y. But our shape for the circle has the radius, so that also has to have a get radius. So these get and sets are very typical in Java because when you have something as private, the only way you can access it is through a get. When you have it as private, the only way to give it a value is through a set, unless you call it in as part of your constructor parameter. Okay? So this just means I'm going to have all these different variables. Two of them are defined, and I could use it from the abstract class. One of them is not. It is then used from the defined in the child class. Okay? And remember, we always have to have a call to a constructor to call the parent class. That was something you maybe saw when you're doing your base and child class. In order to inherit, just because you use that extend word, that's not enough. Yes, for the radius, yeah, the user would input it, as they would input also the X and the Y, because they're not given values either. So this part of the constructor. So we can, remember, you can sometimes call a class with something in the parentheses or something without in the parentheses. Okay, by the default is empty parentheses. But typically, if you have values, you want to pass it to the class, then you would pass it through the constructor. Again, this is the API reference library. All methods have, classes have constructors, and they may have a variety of constructors. This is called a polymorphism, so that it can be used in a variety of ways. Maybe I'm not passing it any values. I have to be able to use the class without any numbers to give it. Or I have to have a way of using the class with numbers to give it. And again, that's always illustrated in the API reference library. That's how you can see if there's more types of constructors. Okay, so these are our numbers. We have an X and a Y and a radius. All right. Final, as I mentioned, means I'm creating this abstract class, and the reason I have final there is because you have to have an X and a Y. You're going to have a shape, and if you're going to draw it out, you for sure have to have an X and a Y. Okay, so that's why the final is there. It's kind of just ensuring that you use it. Again, when things are in a library, they have to be written in a way that they all will always work. And this is a way to enforce it and make sure that it works, because somebody should not be using this and not using the X and the Y. Okay, this I'm just going through. This is revisiting. We already talked about that. Okay, so now these are the constructors, right? Okay, so when you have a child class, we know we can use the extend word, but we also have to call super. You've probably seen that already. So I called my super, and right here now, my X and Y are 0, okay? And my radius is 1. So I automatically assigned it. It was not input. I'm sorry, it was not input at this point. You did ask me that, didn't you, Nathan? Right. But this should be written in a way that it should be taken in as a input. Okay. So a lot of ways to write your class. So here, though, we're just initializing everything. X is 0, Y is 0, and radius is 1. Then we have another way of calling it. We can call it by giving it the values. And that's when we call it. So this would. So does the final not mean that the X or Y value is final? It means that you have to have you can't change this definition. It just means you can't change it, okay? It's final. This definition of how to get the X and what the Y and how it's used throughout the program has to be done this way. That's what the final means. Right, definition, not value. Right. But once it's given a value, it's not going to, well, no, right. Definition, not value, correct. You need to have an X and a Y. And you can't redefine this. I can't all of a sudden say, my X is going to be my Y, and my Y is going to be my X. This is going to stop you from doing that. Or my X is going to be my Z, and my Y is going to be my A, you know, right. So, now, the one way I'm initializing the 0 and zeros with the X and Y is when there's no parameters, right? But when I use this, so this is where you would have a person enter an input. And this input, again, when you are using this, you're not going to use either of these classes directly. You still have to have a static main. And that static main will then ask a user for this information. So that does come into play. So when I call circle, that first time, public circle int, so I have X location, Y location, and radius. So that information is going to be passed to when I call this new, when I do the new keyword. So I'll show that when we get to that test case or the demo class so that it actually launches this class. But if you can see how this is already tied with the abstract class. You have to use the super, right? If you have a constructor that doesn't have any variables, then the supers are not going to be called with any variables, okay? If you have variables that are being passed to your class, then your super is going to be passed those that apply to it. So the X location, Y location is passed over to shape. Okay? Does that make sense so far? Maybe when we actually use it, it'll make better sense. So there's your super. That's when we're calling the parent class and initializing the parent class. Just by using extend is not enough. You have to also now initialize it. Okay, so everybody clear on the super? Is that part clear? And then with calling the one constructor with values, we pass those, the ones that apply to the super, like here, the X and Y. If we are not passing any values to the constructor, then we can't pass anything to the super. There's nothing to pass. This means it's just this program, this value. This is just a kind of a shortcut. I'm not a fan of using the this because this can be kind of confusing at times, but some programmers do. It's just a shortcut. But this would be the circle class, right? So this here, the only class that has a radius would be the circle class, right? And the only class that has the X position and Y position is the super class. So it's just kind of identifying the this with the circle when it's in the circle and the this with the shape when it's in the shape. But again, I prefer using the full path name, but you can use whatever would make sense for you. And then here are some other methods to get area and stretch by. Again, it's not defined in the abstract class because it can't be, because areas differ, but it is defined in the circle class. This is how you get the area for a circle, and this is how you increase the shape of a circle if you want to make it larger. So it's completely defined in the shape class. And then here, now we have a toString, right? So we have something that's called a toString. But since there's no final in this public string toString in the shape class, I can redefine it. So that's another, the final does not allow you to redefine it, right? The definition. Here though, since I don't have a final, I can. That makes sense, right? So all this is helping you just to format the output statement. Because remember, if something is a number, you have to convert it to a string to display it. You want, especially if you want to concatenate. So this is just a way of making one large string of a sentence in presenting your result. The one that's in the super just says, hey, you probably want to put out this information, but when I have the circle class, I'm going to be a little bit more explicit what I'm talking about. I'm talking about a circle and so forth. And I need to include additional stuff. In addition to my X and Y positions, I have to include the radius, and I'm going to include the area. Because radius and area is defined in the circle class. This other part, X position and Y position, is defined in the super class. The other one is defined in the circle class. Does that make sense? Do you see how some things are defined in the parent class or abstract class, and some are defined further in the child class or the concrete class? Yes? I think this will take time to go through. Okay. But yeah, just so you know, the abstract class is kind of like a parent class, but not exactly because it's not fully defined. And then when you want to use it and make it concrete, some of the things are defined already for you to use. Some things you can't change, some things you can change. Some things you have to include, some things are optional. And there's your super, as I mentioned before. Okay, here's an example again. Let's see, we're going to see the same example, but now we're using the shape abstract class to calculate a rectangle class. Very similar, right? Except we know what? There's some things when it comes to rectangles that was different than a circle. But we have the same shape class. It's still your abstracts. I'm still going to extend it. Right? I'm still going to have my different variables here. But I really don't, do I have anything different? We have an X and a Y and a height and a width. Right? Here's the same thing. We call the super. If we have information in our parentheses, we pass it to the super. If we don't, then we don't. Okay? The X and Y is always with the super for the abstract class because that's what we already established. It always has an X and a Y. Everything else, if you need something more for your shape, is then defined in your child or concrete class. And same thing, the get area here and the stretch by is going to be fully defined for my rectangle. It was fully defined in the previous example for a circle. Now it's fully defined for the rectangle. And the two strings, same thing. I just extended the information of what I want to print out. Part of it I could use from the two string because we know we had an X and a Y, but now we want to add other words. Okay. Yes. Do you have a question, Nathan? Are you typing a lot? Is that what's taking the time? Or just go ahead. Oh, it's just a way of initializing it. You could say width equals 0, height equals 0. It's just a shortcut that you can do in Java. That's all. So same thing as width equals 0, height equals 0. Just a shortcut. Yeah, you know, just like the this. You'll find there's like little shortcuts here and there, and it can kind of be confusing at times, but well, now you know another way to do it. Okay, so here we go. Now I have my static main. Remember, we can't use classes directly. Definitely can't use an abstract class directly. We need to have our static main. This is now how we initialize and get everything going. So we have the new circle. So this is going to do a circle and a rectangle. And we know for the circle, we did look at it. There was a way to pass in information. Okay. Right here, I'm just giving it 1, 1, 2. But if you wanted to, you could ask your user for input. So this would be a time when you can say, hey, you know, specify this information for me. This is just a quick way of testing our program, but not necessarily a real world type of an application because we're giving it the values. This is just testing. So that's why it's called a test shape class. Okay. And then we're going to move it, move 2, 3, 3, stretch 5, 2, 5, 2.5. And then system out, print line, circ string. And then same thing with the rectangle. We're going to give it the values. We're going to do our move to and our stretch by and our print line. So this is going to be our output. So what is from shape and what is from circle, right? We knew some of these were defined in our shape class, or abstract class, and some of that was abstract, but that had to be defined in the circle or the rectangle class. So this is a good way for you to understand what's coming from the abstract class, what is being defined by the circle class, and what is being added by the circle class, because that'll give you an understanding of how you use abstract classes. What are you capable of doing? So this would be an answer. This is what you would get. As we know that string, two string, for example, the XY position 4, 4, that came from super, right? That was one information that the shape class had, and that was the X and Y position. That was all it had. The radius came from the circle class. The calculation for the area came from the circle class. Same thing. And even the word circle came from the circle class. And same thing for the rectangle. So this is a way of showing you that. Again, so what is from the shape and what is from the circle? And then here you know it's that one line, x, y, position, 4, 4. That was that 2 string. Okay, any questions on that? Yes, no, maybe so? I think you'll take a look at it, but I think for your an example, for your assignment, you have to do circle, rectangle, triangle. Right? I don't know, I'll get there. I did write it. It's in here. Let's do what the specifics are. Okay, multiple inheritance, you're going to review that in your discussion forum, so I'm not really going to go into this too much. This will be here, and it just shows how you could use an interface in order to simulate multiple inheritances. Okay, so here's your week 5 assignment. You're going to create a circle, triangle, and rectangle. So you already have the circle and the rectangle done. Now you just have to do the triangle. How do you calculate the area of a triangle? Anybody know? You can Google it. You know how to do the calculate? Yeah, the area of a triangle. We already saw the area of a circle. 1/2 pi r squared. That's for a triangle. Okay. Everybody else, what do you think? Well, see, that'll be part of what your assignment can be. So you want to do these 3. You already got the code for the 2, so it's a matter of now understanding the code enough to get it to do the triangle. But also, you maybe want to include input from a user. See if you can work with the program and make those changes. Again, you are in control of your programs. I think you have to understand that you are. It's not going to just, it doesn't get taken over by the computer. You're in control of everything that gets done. So it's up to you as to how you fashion it to make sure that it gets everything done. And then create another class that extends above class and provide implementation of abstract methods. Okay, so that's the shape. And then you're going to have the rectangle, and then you're going to have the triangle. So this is just the same thing that you have. Now, your course project. Create an interface called as the patient and then implement the interface as well as all of the above methods. I'm sorry, not from week 6, but from week 4. So whatever you have in week 4, now see if you can do an interface called a patient. Okay, that'll give you an understanding of what an interface is and how to write it. You're going to write for the week 5 individual assignment. You're going to create the abstract class and then the 3 concrete classes, and that's going to be the circle, the rectangle, and the triangle. And again, you're going to show your outputs. You need to have your test class. So you can use everything that's there, just include a definition for the triangle class that extends the shape class, and then have it output. The same examples that are output are fine, and then just add some information then for the triangle. And then now you're going to create an interface for the patient class. So this will give you a good understanding of the difference between an abstract class and an interface. And so that'll be part of, I think you're going to research it a lot in your discussion. So that's why your discussion is talking about interfaces and abstract classes. So get a good understanding of the interface so that you can create one for a patient and then be able to use it in your course project. Does that make sense? Any questions? Are we good? I should have had more information on creating. Well, you have the abstract, and you have then how to use an abstract class to make it concrete. Yeah, the only thing I'm lacking here is probably an example of an interface, but that is something that then you can explore and understand. If it's easier for you to make an abstract class as a patient, that's fine too. That's acceptable. If you have a hard time with the interface, then just make an abstract patient class, and then use it in your course project. And again, remember, the course project has a variety of elements. You may not get all those elements completed, which is fine. And you're still going to get, pass the class. It's not your entire grade is not based on the final project. But do the best you can and keep working on it even after the class is ended, because that's how you can improve your programming style and your programming skills. So any questions so far? Yes, no? Are we good? Oh, the keyword. Okay. Keyword is going to be interface. So the keyword is interface because that's what you got to create. So are we good? Are we understanding the assignments? Does everybody understand the assignments, at least in theory, what you have to do? And again, the course project, you can do an interface or you can do an abstract class. Actually, I'm going to leave it like this. You can do an abstract, an interface, or a concrete class. Whatever works for you. So that'll definitely give you to know. So for the course project, you can either create an interface, abstract class, or concrete class. Okay, so for the course project assignment, you can either create an interface, abstract, or concrete class known as patient. That's all of them will account for this assignment. You'll have the opportunity to explore abstract anyway when you're doing your week 5 assignment. And then in the discussion forum, you're going to discuss creating interfaces and that. But I don't think I'm going to make you create it for this project because typically you wouldn't do that. You wouldn't create a interface known as a patient. That's kind of like out of the scope of what a typical interface really is. You may have like an abstract class known as a person, and then you would make it into a concrete class as a patient. That's more in line with how you would be using these people classes. So that's why I don't know if you want to use that. So again, I didn't develop these assignments or these instructions, but I am modifying them here for you so that you can do whatever way works for you. But again, you already have an idea of how to do classes because you did do parent and children. But now you know your patient class is going to have information so far that you've been already gathering about the patient. And this way you can have that as part of your class. And then your static main can do the calculations to determine the BMI category and insurance category and so forth. Does that make sense? Any questions? Yes, no, maybe so? Are you all still there? Hello? Hello out there? Okay, thank you. Okay, good. So that's all I got. Then have a great time in the classroom, and good luck with everything. And I will be doing grades hopefully by today, if not, for sure by Wednesday. Just some things came up. But if you submitted it, that means you probably had it already successfully running. And if you didn't, keep working on it. And please do, if you are done, help your classmates out. And I've seen a lot of good collaboration, which is great. I think it's important. And again, when you help someone else out, it reinforces the idea. Yes, there'll be our last classroom will be Monday. That is correct. Great question. So we will have one more, and next Tuesday is our last day. So hopefully everything will be in by next Tuesday. And have a great day. Enjoy, and we'll see you in the classroom. You too. Stay healthy, everyone. Yes.